Welcome to Frost Astrophotography. Earlier in this season, last year, I started a project with some of my friends for Abell 85, CTB1, the Medulla Nebula, the Popped Balloon Nebula, among other popular names of it. We have been gathering data with different telescopes and cameras, and I've actually not been able to use the accumulated data from all of my friends due to the fact that I need to learn how to process that in a good way. The Medulla Nebula is a supernova remnant that is very faint. It requires a lot of hours, and that's why we decided to collaborate in the first place. But until that image has been processed and I'm happy with it, you will have to make do with the image of Medulla Nebula using my data. Here we are starting processing of CTB1, a very faint supernova remnant. It is also known as Abell 85, but that was before it was known that it was a supernova remnant and not a planetary nebula. It certainly becomes apparent that this object is very faint because you are looking at about 85-minute frames of each filter here with a total combination of about 20 hours. And as you can see, even in the H alpha here, it is very faint, almost not visible here in the O3, a little bit more visible in the S2, but not much. So obviously this is going to take some processing to pull out. I'm going to take you through my normal steps before we are going to make a somewhat new blend of HOO this time. I'm going to show you one of the frames, HA, as usual, since there is not much difference between them. So I started off with a dynamic crop as usual. I then did a dynamic background extraction. You can't see that much difference between them, and that is because we have a lot of nebulosity or HA data, I would say, in the background here. I then did a linear fit, and since the HA was a reference frame, there's not much of a difference on that one. My next step would normally be deconvolution if I am using PixInsight native content only, but in this case I've used the blur exterminator. And as you can see, we have some sharpness of the object, and the stars are noticeably smaller. You can also see the object a bit more in the middle here, with the stars not so prominent. I also did a noise exterminator, and that resulted in that you can see the object a bit more. And there's also a bit more difference now between what is exactly HA data here and what is the background. And that concluded the first steps in the linear phase, going from what you see on the left here to what you see on the right here. After the manual stretch using the histogram transformation, I usually do starless versions of the filters before making an SHO, HOO forex, or any other type of blend. I did that in this case as well. First of all, I did a starless version of the HA filter. I then did some noise removal and ended up with the image to the right here. Quite a difference between the two. Same for the O3. Starless and with noise reduction. There is quite a big of a difference between these two, but there is not much O3 data in this image. And considering this is about 7 hours of O3. And finally, I did the S2 starless version and with noise reduction to the right here. I was thinking about the blend, but I decided that I would go with an HOO mix this time, only using two filters, H-alpha and oxygen 3. And this was my initial blend. I then did some initial color adjustments, and I also adjusted the background and some contrast and saturation to make the main object pop out really good. I used my normal tools, and that is multiscale linear transformation to really bring out the details, unsharp mask to sharpen the image, and then TGV denoise to remove some of the noise inside of the object here. And it's not a very high resolution for me, I'm afraid, but zoomed out, it's okay, I would say. And some final color adjustments and also a final curve adjustment to get the image that you see here. I decided to use HA stars for this image because I didn't really gather any RGB data for this object, or at least I haven't done so yet. So I still have the possibility to revisit this object get some RGB data and make a new blend to add RGB stars to this image. So before joining these two together, I reduced the star some more, even though I've already run the blur exterminator on these stars before making a starless version and a star image. And here we have the final image, the CTB1 Supernova Remnant with 20 hours of narrowband data, although I only used 2 filters for this HOO blend. I also did an SHO version during this processing just to see how it turned out. And this is the results of the SHO mix or blend. I kind of like the HOO better for this object, but the SHO is nice also. There's no arguing with that. And I'm planning on revisiting this target at a later date. As I stated in the beginning, this was supposed to be a joint venture with some friends, fellow astrophotographers in Sweden, to see what we could come up with using our different telescopes and cameras. I must say it has been really challenging to find a processing workflow that is able to let me blend narrowband, broadband, and different focal lengths, different telescopes, and also different rotations on the images to make it into a single seamless image. I'm going to practice that one, and then I'm going to revisit this in a new video to see if I can present something that has about 60 hours worth of data instead of 20 as it is right now. Thank you so much for watching this video, and if you like it, please give it a thumbs up and consider subscribing if you're not already doing so. If you want to support me and the work with these videos, there is an option listed in the video description. Until the next video, I wish you have clear skies.